This says, calculate to 3 significant digits the density of dinitrogen difluoride gas at exactly minus 15 degrees C and exactly 1 atmosphere. So this is basically a question where we have to calculate density. And if you recall, density equals mass divided by volume. For gases, usually the mass is in grams and the volume is in liters. So it's grams per liter. So the first thing we have to do is make an assumption. Let's assume that we have 1 mole of dinitrogen, N2, difluoride, F2. So let's assume we have 1 mole of M2F2. And to find its mass, we just find its molar mass, because 1 mole is going to be equal to the molar mass. So it's 2 times 14.01 grams plus 2 times 19.00 grams, just from the periodic table, which equals 66.02 grams. So that's the mass. We can plug that in. 66.02 grams divided by the volume in liters. Well, I think you could probably guess, because we're in the ideal gas law chapter, that we're going to use the ideal gas law to find this. And the ideal gas law is P, pressure, times V, volume, equals N, the number of moles, times R times T. If we divide both sides by P, because we're looking for volume, V equals nRT over P. So we assume 1 mole. So N is 1 mole. Note that we're going to just round this to 3 significant figures. Even though you could argue this is 1, it's an assumption, so it doesn't really have sig figs. It's not actually a measurement. Okay, R is the ideal gas law constant, 0.08206, and that's liter atmospheres per mole. Okay, times the temperature in Kelvin. Well, we're given the temperature in Celsius, so we have to take the minus 15. We have to add to it 273. And what we end up with is 258 K. So we can plug that in, 258 K. Divided by the pressure, it's exactly 1 atmosphere. So we plug in our 1 atmosphere. When you do all that math, you find out that V equals 21.171 liters. Or probably this is a sig fig, because the temperature is actually a measurement, and that'll give us our 3 sig figs at the end as well. So plugging in for our volume, 21.171 liters. Remember, density equals mass divided by volume. We found the mass because we found the molar mass, and then we found the volume using the ideal gas law, as shown here. So now we take our mass, we divide by our volume, and to 3 sig figs, we get 3.12 grams per liter as the density of dinitrogen difluoride at minus 15 degrees Celsius and 1 atmosphere of pressure.